So today we're going to quickly go over confidence intervals, but for proportions. Okay, so they're going to be a little bit different from confidence intervals for means. We have a formula here that we're going to use, and then when you finish that, we've got some practice tests for you, so you can start revising tests this time next week. So here's the formula for a confidence interval for proportions, and I'm going to explain what it means in the context of the problem. So just sit down, Brad, you can sort yourself out at the moment. Yeah. Alright, so let's say we did a sample of 50 people. Alright, sample of 50 people at Tennyson Woods College, just sort of all ages, and we found that 50 of them had blue eyes. Okay, so that means our observed value for the proportion, we call that P hat, because it's got a hat on it, P hat. So P hat, not fat. Okay, so P hat is going to be 12 on top of 50. That's our value of P hat. Okay? Our value of N is how many people we sampled, which is 50. And then we have all the information we need to calculate this confidence interval. I'm going to put P hat there. I'm going to put P hat in there and there. One take P hat, what's that going to be? Okay? If we have 12 out of 50, that's 0.24. Okay, so 24% of the population have blue eyes. It means one take P hat, that's the inverse of it. That means 0.76% of the sample, I should say not population, of the sample, don't have blue eyes. Okay, so that's the inverse of it. So we have P hat times the inverse of P hat on N. So we're just going to put all that information into our calculator to calculate the lower boundary and the upper boundary, and then we're going to make a statement about what it means. So let's smash that. So we have 12 out of 50. Two, 1, 6. Okay, so then the three significant figures. Alright, so I've calculated that there. I've got the lower boundary and the upper boundary. So remember, P hat, okay, P hat is the our sample, our observed proportion. That's what we get from observing, from the experiment we've performed. And then P is the proportion of the population. So we're using a sample to make an inference about the population. So based on this statistical analysis, this is a 95% confidence interval, we are 95% confident that the true proportion of people that have blue eyes is somewhere between 12.2% and 36%. Okay? That's the maths that we performed here. We're 95% confident it's in that window there somewhere. Okay, so that's what it means to interpret it. So these are the questions we'll be working through today.